Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the probability rules. So we've been talking about probability and how to calculate it, and now I want to get into some actual rules with probability, and of course, again, we'll do lots more examples. First of all, the probability of an impossible event is 0. So the likelihood of it happening is 0 if it's impossible. The probability of a certain event means it will happen is equal to 1. And the probability of any event is always going to be between 0 and 1. So the probability of an event that I'll call A is greater than or equal to 0. So if it's equal to 0, it means it's impossible. And it's less than or equal to 1. So your probabilities will be somewhere in the range from 0 to 1. The sum, which means adding, the sum of all the probabilities for all possible events is equal to 1. And let's take a look at an example so I can show you how this works. Okay, let's say we put 6 red candies, 10 green candies, and 14 yellow candies in a bag and shake them up. We then choose one candy from the bag. So we're going to look at the probability of it either being red or green or yellow and add up those 3 probabilities, and the sum should equal 1. So first of all, the probability that the candy is red. Well, how many ways can it be red? There are 6 red candies, so there are 6 ways it can be red. Out of how many possible outcomes? We have 6 plus 10 plus 14 candies, so we have 30 candies altogether. So the probability of it being red is 6 over 30, which we can then express as a decimal, 0.2, or 20%. We do the same thing with green. What's the probability of that candy being green? There are 10 green candies. So the probability of that candy being green will be 10 out of the total number of possibilities, which is 30. So that's going to be 0.33 if we round off. And lastly, what's the probability that it'll be yellow? There are 14 ways it can be yellow out of 30 possible combinations. As a decimal, that's going to be 0.47. So, because these are the only 3 possible outcomes, our rule says that the probability of picking a red candy plus the probability of choosing a green candy plus the probability of choosing a yellow candy should equal 1. Well, let's see, 0.2 plus 0.33 plus 0.47. We add these up, it does indeed equal 1. This next rule is called the complement rule, and it states that the probability of the complement of an event is equal to 1 minus the probability of the event. So the complement means the opposite. The notation that we use for complement is this. So that's the complement of A. So the probability of the complement of A will equal 1 minus the probability of A. So let's take a look at an example. Let's say our event A is if we were to roll a die and the event is rolling a 2. The complement of that would be not rolling a 2. So if we looked at the probability of rolling a 2, so the probability of event A would be how many ways can we roll a 2? Well, there's only one way to get a 2. How many possible outcomes are there when you roll a die? There are 6 possible outcomes. So that's the probability of our event rolling a 2. If we want to know the probability of not rolling a 2, we would simply subtract this probability from 1. So 1 is 6/6 minus 1/6 would be 5/6. And we can check that because we know there's 5 ways not to roll a 2. If we roll a 1 or a 3 or a 4 or a 5 or a 6. So there's 5 ways not to roll a 2, and there's 6 possible outcomes when we roll a die. So hopefully you can see that this makes sense. The next rule is the addition rule, and there are 2 parts to it. So the first part deals with 2 events that are mutually exclusive. And by mutually exclusive, it means that they have no outcomes in common. If that's the case, then the probability of A or B happening will equal the probability of A happening plus the probability of B happening. And the notation that you will see for OR is this notation. Let's take a look at an example. So in this example, we're asked to choose a card from a deck of 52 cards. What is the probability of choosing a diamond or a heart? So the first question to ask yourself is are these events mutually exclusive? Can something be both? Or if it's one thing, it can't be the other. So they have no outcomes in common. These are mutually exclusive. A card can't be a heart and a diamond. It's either a heart or a diamond, or it could be a spade or a club. So these are mutually exclusive events. So the way we find the probability of one or the other is with this formula. So the probability of a heart or a diamond will be equal to the probability of a heart plus the probability of choosing a diamond. So let's find the probability of choosing a heart. There are 13 hearts in a deck of cards. There's 13 hearts, 13 diamonds, 13 clubs, 13 spades. So the probability of choosing a heart, there's 13 ways you can choose a heart out of 52 cards. So that's the probability of choosing a heart, which you could reduce if you want. And the probability of choosing a diamond, same thing. There are 13 diamonds in a deck and 52 possible outcomes. So the probability of choosing one or the other is going to be 26, 52, or 1/2, or 0.5, or 50%. So this works for mutually exclusive events. Sometimes you're going to have events that are not mutually exclusive, so the formula looks a little bit different. Let's take a look. If two events A and B are not mutually exclusive, then the probability of A or B will equal the probability of A plus the probability of B minus the probability of A and B. This symbol means and. And to illustrate this, let's take a look at an example. Again, we'll do a card example. We are choosing a card from a deck of cards, and the question asks, what's the probability of choosing a diamond or a face card? So you have to understand a little bit about cards and what cards are in a deck. So there are 13 diamonds in a deck. And face card, it refers to a jack, a queen, or a king. So there's 3 face cards in each suit. There are 4 suits. So there are 12 face cards in a deck. So what we're finding is the probability of choosing a diamond or a face card. And that will be equal to the probability of choosing a diamond plus the probability of choosing a face card minus the probability of choosing a face card and diamond. And the reason that we have that in there is we don't want to count a diamond face card twice. So let's find each of these probabilities individually. The probability of a diamond, there are 13 in a deck of cards. So our probability is 13 over 52. The probability of a face card, as I mentioned, there are 12 face cards. So the probability of choosing a face card is 12 over the total number of possibilities, 52 cards. And the probability of choosing a diamond and a face card, well, there is a jack of diamonds, queen of diamonds, and king of diamonds. So there are 3 out of our deck, which is 52 cards. Plugging that in to our formula, the probability of choosing either a diamond or a face card will be the probability of choosing a diamond, which is 13 over 52, plus the probability of choosing a face card, which is 12 over 52, minus the probability of choosing a diamond and face card. That probability is 3 over 52. So we add 13 and 12 to get 25 minus 3, 22 over 52. When we reduce that, we get 11 over 26, which we can leave in fraction form or express it as a decimal. Okay, so we've got a question here. It says a neighborhood was polled and it was found that 60% of the families in that neighborhood had a dog, 45% of the families in that neighborhood had a cat, and 20% had both a cat and a dog. If you randomly selected a family, what is the probability that they would have a cat or a dog? So this word or means cat or a dog. So ask yourself, are these events mutually exclusive? If they have a cat, can they also have a dog? Yes, they can, so they're not mutually exclusive. So the formula we're going to use probability will be found by taking the probability of having a cat plus the probability of having a dog minus the probability of having a cat and a dog. So in this case, probability of having a cat is 45%, which is 0.45. The probability of having a dog is 60%, so 0.6 or 0.60, minus the probability of having a cat and a dog, which is 20%, or 0.2 or 0.20. So the probability of having a cat or a dog will be 0.85 or 85%. This question is a little bit different. It tells us the probability that James will study on Friday night, 0.4 or 40%. Tells us the probability that he'll play video games Friday night is 60% or 0.6. The probability that he will do at least one of these activities is 0.8 or 80%. So the question asks, determine the probability that he will do both activities. So we're going to use our same formula. The probability that he studies or plays video games will be equal to the probability that he studies plus the probability that he plays video games minus the probability that he studies and plays video games. This time we know this probability is 80%, so 0.8. The probability of studying is 0.4. The probability of playing video games is 0.6. And what we don't know is the probability of doing both. So we're going to solve this. 0.8 will equal 1 minus this probability. We can call it x if you are more comfortable with that. In order to solve this, we're going to add an x to both sides and we're going to subtract a 0.8. So x is equal to 0.2. So therefore, the probability of studying and playing video games is 0.2 or 20%. So that's part A, determine the probability that he will do both activities. And then B, are these events mutually exclusive? The way that you know they're mutually exclusive is whether or not this value here is 0. Because remember, our formula for mutually exclusive doesn't include this term. So that means that the probability of both events happening is 0. Because it's not 0, they are not mutually exclusive. There's one more probability rule that I want to discuss, and that's called the multiplication rule, and that will be covered in the next video. See you then.